In this video, we're going to take a look at how to analyze a polynomial function by looking at its real zeros, multiplicity, determining whether the graph crosses or touches the x-axis for each intercept, looking at the graph's turning points, and looking at its end behavior. Suppose we have the function f of x equals -3 times x minus 2 times x plus 8 squared. Since this polynomial function is already factored for us, we'll start by looking at each factor. Our first one, x minus 2, and our second one, x plus 8. First, let's look at the zeros of each factor. To find the zero of each factor, we simply set it equal to 0 using the zero product property and solve for x. So one of our zeros is x equals 2. For our other zero, subtracting 8 from both sides, we have x equals -8. So in other words, our zeros occur at the points 2, 0, and -8, 0. Now let's take a look at the multiplicity of each of our factors. For x minus 2, for factor x minus 2, we have a multiplicity of 1. The reason why it has a multiplicity of 1 is because the factor is raised to the first power. And let me go back in and write the 0 for this factor. Okay. Now for the factor x plus 8 squared, it has a multiplicity of 2. The reason why it has a multiplicity of 2 is because the factor is raised to the second power. To determine whether each factor crosses or touches the x-axis, we look at its degree. In other words, each factor is raised to a power. That's its degree. For x minus 2 to the first, the multiplicity is 1, and because that's an odd multiplicity, we know that the graph is going to cross the x-axis. It crosses the x-axis due to being an odd power. Or odd multiplicity. For the factor x plus 8 squared with a multiplicity of 2, it's going to touch the x-axis at the 0 and change direction. X plus 8 squared touches the x-axis due to even multiplicity. Since the multiplicity is even. Now, to determine the number of turning points on this graph, we look at the overall degree of the polynomial. The degree of the polynomial f of x equals minus 3 times x minus 2 times x plus 8 squared is degree 3. This is a third degree polynomial. For any polynomial function of degree n, let me write that down. For a polynomial function of degree n, the maximum number of turning points on the graph is at most n minus 1. Since we have a third degree polynomial, we take degree 3 minus 1, and that gives us 2. That means that 2 is the maximum number of turning points on our graph. So our maximum number for our example is 2. Actually, I'll write that as 3 minus 1 equals 2 possible turning points. To determine the end behavior of a graph, we consider the overall degree of the polynomial and the lead coefficient. For our polynomial, the lead coefficient is negative 3, and the overall degree of the polynomial is the third degree. So, the end behavior of our graph is f of x equals negative 3x cubed. What this means is that the power function that our graph resembles for large values of the absolute value of x is negative 3x cubed. This concludes our example. I hope you found it helpful, and we'll see you next time.